Hey guys, welcome to Safi Mixed. In this video, I want to derive the relation for the difference formula of cosine function by considering a circle. Generally, a unit circle is considered, but I would like to consider a circle of radius r. And for that, I first draw a circle. So I consider this as a circle, and let this be the center of the circle. I take x-axis in this direction, this is positive x, and y-axis in this direction, that is the origin of our coordinate system passing to the center of the circle, and let r be the radius of this circle. Then I consider a point here, and I call this point P, and locate the terminal side like this, and this is the angle theta. Then first I want to locate the coordinates to find the coordinates of point P on the circle, and that I do by dropping a perpendicular from this position on this point. So this is along negative x-axis. I call this P sub x, and I call this P sub y, that is along the positive y-axis, and this angle is then equal to pi minus theta, because this whole angle is equal to pi, and pi minus this angle is equal to pi minus theta. Now I have constructed a right angle triangle whose right angle happens at this position, and we know about the value of this, which is r, so we know the hypotenuse. Therefore I can find p sub x and p sub y in terms of these two parameters, and this is the base. Px is the base, so using the trigonometric ratio, so using the ratio of the sides, I can write px, p sub x equals r cos into pi minus theta, and r cos pi minus theta equals minus r cos theta. So we know this relation, that cos pi minus theta equals minus cos theta. Therefore I can write this thing as minus cos theta, and I'm writing the minus with here. And similarly for perpendicular, using the ratio, I can write py equals r sine pi minus theta, and we know sine pi minus theta equals theta, so I write this as r sine theta. Therefore the coordinates of point P, which I write over here, P is in fact, these are the coordinate minus r cos theta and r sine theta. I better write these coordinates somewhere over here. I want to write this here, P. The coordinates of P are minus r cos theta and r sine theta, because I'll be using these coordinates later. Now I take another point on the circle, and I represent that with Q, and the position vector is then this, and I call this angle phi. I can again find the coordinates by dropping the perpendicular over here. Then from this point to this point, this is q sub x, and this is q sub y, and then this angle equals pi minus phi. If I use the same relation just by replacing theta with phi, I'll get qx is equal to minus r cos phi and qy equals r sine phi. So I write these coordinates of point P at this position. Point P is in fact, point Q. The coordinates of point Q are minus r cos phi and r sine phi. Then this angle between P and Q, let me call this one angle. This angle, this whole is equal to theta and this is equal to phi. So this angle is in fact equal to theta minus phi. The separation, the angular separation between point Q and P is equal to theta minus phi. And now I take a third point on this circle from, let me call this point A. On the circle, somewhere at this position, such that, let me call this point R, such that the angular position of R with respect to x-axis is exactly equal to theta minus phi. That is, the angular separation between Q and P is exactly equal to the angular separation between A and R. Then I can find the coordinates of point R. This is Rx and this is Ry, and again this is a right angle triangle. So Rx, by using the ratio, is in fact given by, and obviously this is R, so I can write R into cos theta minus phi and Ry equals R sine theta minus phi. So I write the coordinates of R at this position. Coordinates of R is R cos theta minus phi and R sine theta minus phi. Okay, with the coordinates in hand, now we can find the distance between A and R and the distance between P and Q. So I have the coordinates, therefore I don't need these equations, I can remove them. And now the general formula for the distance between any two points is given by square root the difference between coordinates along x-axis square plus square of the difference between the coordinate along y-axis. That's what we know from the distance formula. And if you don't know the distance formula, I will click on the link in the description of this video. I have a detailed video on this thing. Now, since the angular separation between this and this is same, therefore this distance must be equal to this distance. But before coming to that point, let me first write the equation for this distance. We see that the coordinates of point P with respect to x-axis, of point A with respect to x-axis are just 1, not 1, R and 0. Because this point is lying along x-axis and the distance from the origin to this point is r, so the x-axis coordinate is r, and there is no coordinate, and the y-axis coordinate is at y is equal to 0, therefore the y coordinate is 0. Now the distance between these 2 points according to this equation can be written, let me write this as distance between A and point R is x2 is the x component of coordinates, the x component of point R, which is this. So I write R cos of theta minus phi, and x1 is R. So I put, oh, this is not capital R, this is small r, minus R whole squared. And similarly, the y component of R is R sine theta minus phi, and y1 is 0. So I write that plus R sine theta minus phi minus 0. Let me write this be close to this point, and then taking the square root. Similarly, the distance between these 2 points, which I write here d, between P and Q, between Q and P equals, since P is far from this point, therefore I'll take the largest distance. It becomes, according to this one equation, the coordinate along x-axis of P we have written minus R cos theta. So I write that as minus R cos theta, and then minus x1 is the coordinate of Q, which is minus R cos phi. So I write that as minus R cos phi, and then the whole squared, this one squared. And then let me write the second part y2 at this position, plus y2 is the coordinate of R, which is R sine theta, and y1 is the coordinate of Q, which is R sine phi. So I write that R sine phi squared. This whole square root comes on this too. Now, since the angular position or the angular separation between A and R is exactly equal to the angular separation between P and Q, therefore this distance must be equal to this distance. That is, distance between point A and R is exactly equal to distance between Q and P. So if I substitute this value for this and this value for this, and I can write square root R cos theta minus phi minus R whole squared plus here is a square, I missed the square, so this square is there, R squared sine squared theta minus phi, because minus 0, so I just take the square of this and square of this. This must be equal to, as per this equation, to this thing, so I write this as square root minus R cos theta plus R cos phi whole squared plus R sin theta minus R sin phi whole squared. Let me square the equation. If I square this, I will remove the square root so I don't write that again. So squaring the equation will leave me with this thing, right? I just remove the square root. There is no square root on this, and there is no square root on this side. So squaring the equation will give me this form. Now I can use a minus b square formula to square this thing, and before that I can take square r squared common, so I write r squared into, then I have cos and 1, so that would give me cos square theta minus phi plus 1 and minus 2 cos theta minus phi, and then this term plus r square sine square theta minus phi. That's what I have from the right side. And on the left side, I will write that over here, this thing. Again, I can take r squared common, so taking r squared common, I would have cos phi minus cos theta. So I write r squared into cos squared phi plus cos squared theta minus 2 cos phi cos theta. And from this term, again, I take r squared common, so it get r squared into, and here I would have sine squared theta plus sine squared phi minus 2 sine theta sine phi. So now you see every term on this side, because this r squared multiplies with this whole thing, and there is r squared, I can take r squared common from these two terms, and similarly I can take r squared common from here. So every term on the left and right carries r squared. I can drop r squared, so I cancel this r squared through the equation. And now I can further write this thing. I even do this equation, so I can erase this. Now from this equation, I have cos squared theta minus phi and sine squared theta minus phi. So I combine these two, cos squared theta minus phi plus sine squared theta minus phi, and then I have plus 1 at this position, and then minus 2 cos theta minus phi. And on the right side, I have cos squared phi and I have sine squared phi. So I write the right side like this, cos squared phi plus sine squared phi. And then I have cos squared theta, and here I have sine squared theta, so I write that cos squared theta sine squared theta. Then minus 2 cos phi cos theta minus 2 sine theta sine phi. So I can write that together like this, minus 2 into cos theta cos phi. I'm writing this first cos theta, and then plus sine theta sine phi. Okay, using Pythagorean trigonometric identity, this thing is 1, this thing is 1, this thing is 1. So 1, so I can reduce the relation as 1 and then plus this whole thing, plus 1 minus 2 cos theta minus phi, that's the left side, and then equal to, this is 1, this is 1, so I write 1 plus 1, and this is minus 2, and I can write cos theta cos phi plus sine theta sine phi. Okay, or I can write this as, this is 2 and here is minus 2, so I take that common, 1 minus cos theta minus phi, and the same I do over here, is equal to 2 into 1 minus cos theta cos phi plus sine theta sine phi. I can write it like this. I can cancel 2 with 2. So finally I'm in the position 1 minus cos theta minus phi equals 1 minus cos theta cos phi sine theta sine phi. This one goes with this minus cancel with this, and finally we are left with cos theta minus phi equals cos theta cos phi plus sine theta sine phi. So this is what we call the difference formula for cos function, and that is very important. We can derive several other very good relation by using this one formula, so you just need to memorize this relation, this identity. You just need to memorize this identity. Thanks for watching.